Good morning, student. Let's start today's class. Okay. In today's class, we are going to study about coaxial cable. It is a part of it is a part of guided transmission. In previous class, we have already studied about what is guided medium, and we also studied about twisted cable from twisted cable. And then now in today's class we will see what is coaxial cable. Okay, coaxial cable carries signal of high frequency range than those in the twisted pair cable. Coaxial cable carry very high frequency than the twisted pair cable. Okay, instead of having two wires, coaxial cable has a central core conductor of solid or standard wire, usually copper wire. Okay, and enclosed in a insulating sheet, and this cover with a metal foil, bill or braid, or combination of these two. The metal wrapping short both has a shield again noise against noise and as a second conductor. That means it has that means the coaxial cable has one central. Here you see one central. Okay, that here 1 minute. Coaxial, this is coaxial cable. Okay, this coaxial cable has one conductor. This conductor, okay, this conductor is central conductor. Usually copper is used in this conductor, or at the place of place of this conductor, which is inner conductor. Then it is covered by a insulator. Okay, it is covered by a insulator. Then this insulator covered by a metal wire mesh or foil, metal wire foil, or both of these. These metal wire mesh or foil is called outer conductor. Okay, and and this outer conductor provided shield against noise. In previous classes, we have shown that there are two type of twisted pair cable. Okay, one is unsealed and one is sealed twisted pair cable. In sealed twisted pair cable, there are a wire mesh wrapping around the two conductor twisted together. Okay. Similarly, here also there is a wrapping of metal foil. Okay, or metal mesh or both. Okay, these these layer protect our data from noise and also act as a second conductor. This is central conductor, this is first conductor, and this is second conductor. Okay, then this mesh layer is covered with a also covered with insulator, and and at last there is a outermost plastic layer to protect these things. Okay, this is the construction of coaxial cable. Okay, next come to fiber optical cable. Okay, fiber optical cable is made up of glass or plastic and transmit signal in the form of light. Okay, 1 minute. Okay, in the means fiber optical cable made up of glass, okay, or plastic, and here the data signal transmitted through this fiber optics in the form of light, not electrical signal. Okay, in the form of light. Okay, the light here that light traveled with here the light travel inside fiber optic using this is the main total internal reflection concept, where light ray reflected back to the same medium. That means total internal reflection concept use करके light transmit हुए. Okay, and in the total internal reflection, what happened? The light reflect back to the same medium. That means here see, this is our optical fiber. Okay, the outermost is called cladding, or that outermost is called cladding. This is the glass. Okay, and light travel and return back to the same, and return back and return back and return. This concept, zigzag concept, is due to total internal reflection, and this total internal reflection is happened when there is two condition. Okay, one is when incident angle of ray is greater than critical angle. Okay, and second one is a light is in the more denser medium and approaching to the less denser medium. That means the light coming from more denser medium to less denser medium. First of all, when a light ray coming from one medium to another medium, it tends to bend. Okay, this by using this bending properties of light, we decide a angle, or when the when the incident angle, when the this is the light ray. Okay, this is the incident angle. Okay, when or at which angle the light incident and and the and uh, or what happened when the light incident at which angle that it reflect 90 degree or reflect 90 degree to the next medium. That means when it incident angle I, it not going towards here, it 90 degree reflected. Okay, this is 90 degree, that is reflection. That angle, that incident angle is called critical angle. That means जो एंगल रे, जो इंसिडेंट एंगल रे लाइट रेटा रिफ्लेक्ट हुए 90 डिग्री किंबा दुईटा मीडियम रो जो जॉइंट प्लेस देकी रिफ्लेक्ट करे सेही एंगल को क्रिटिकल एंगल कह जाए. आउ जेतेबेले सेही क्रिटिकल एंगल, जेतेबेले लाइट रिफ्लेक्शन रो एंगल, इंसिडेंट एंगलटा क्रिटिकल एंगल ठारू अधिक हबो है, सेतेबेले कौन करिवो, सी कौन करिवो, रिफ्लेक्ट बैक टू सेम मीडियम, नेक्स्ट मीडियम को न जाइकी सी पळि आसीबो तारे निज मीडियम, सेटा कहते टोटल इंटरनल रिफ्लेक्शन. ओके, आउ लेस डेंसर मोर डेंसर, लाइट ऑलवेज ट्रैवल more denser to less denser. Okay, next we'll see what is unguided media. In previous classes we have already studied about guided media. Okay, in unguided media, transport electromagnetic wave. That means the that means in unguided media, unguided media electromagnetic way without using a physical conductor. That means in guided media, in previous classes we have already studied about guided media. In guided media, there is a physical what physical path or physical conductor through which the data will be transmitted, or the data to be transmitted. But in unguided media, there is no such physical path or physical conductor through which data transmitted. So here what happened? The data will be transmitted wirelessly or in a through a air. Okay, this type of communication is often referred to the referred as a wireless communication. Means unguided media रे जो communication हुए सेटा को wireless communication भी कहा जाए. Okay, unguided signal can travel from source to destination in several ways. One is ground propagation, second one is sky propagation, and next one is line of sight propagation. Okay, what in earth propagation what happened? There is in earth propagation what happened? There is a antenna, okay, transmitting antenna, which transmit the signal, and the data is transmitted very lower layer of our atmosphere. That means low layer रे transmit करे सी. तापर ता receiving antenna रहे receive करे ताको, okay, और receiving device रहे ताको receiving करे. आउ एई propagation कोटी यूज हुए ना हमरो देखिए आगु देखिए ए propagation कोटी यूज हुए. नेक्स्ट होची स्काई propagation. स्काई propagation ला कोन हुए ना एटी कोन अछि एटी गोटे एंटीना अछि एटी गोटे एंटीना रहिबो. गोटे एंटीना ट्रांसमिटिंग एंटीना गोटे रिसीविंग एंटीना. गोटे ट्रांसमिटिंग एंटीना कोन करिवो ना हमर डाटा को हला सी ट्रांसमिट कर दबो रिफ्लेक्ट कर दबो स्काई को. ओके, स्काई को ट्रांसमिट कर दबो. सेटी गोटे हमर आयोनोस्फीयर अछि एटमॉस्फेयर. से आयोनोस्फीयर जो पार्टिकल जो रेडिएशन पार्टिकल और चार्ज्ड पार्टिकल थिबे आयन पार्टिकल थिबे तांको द्वारा सी कोन करिवो रिफ्लेक्ट बैक टू द अर्थ को पळे आसीबो. से सिग्नल जो जाइतिबो से रिफ्लेक्ट करिके अर्थ को पळे आसीबो. हला आउ से अर्थ रे हमें जो रिसीविंग एंटीना थिबो सेतिरे हमें रिसीव ताको करनबा. हला एटा हला स्काई प्रोपागेशन. ओके, एतिरे हाई फ्रीक्वेंसी रेडियो वेव यूज करा जाए. देन द ground propagation. Okay, then come to line of sight propagation. In line of sight propagation what happened? There is two antenna facing to each other in a straight way manner. That means there is no reflection or there is no transmission. One antenna or transmitting antenna is facing straight to the receiving antenna, and the communication straight between these two antennas or travels between these two antennas. Here we use very high frequency. Okay, next we see the wireless communication. Okay, the wireless communication broadly divided three categories. Okay, one is radio wave, one is microwave, one is infrared wave. Okay, these wireless communication uses these three types of waves or three types of frequency ranging waves to transmit data. Okay, in radio wave the wave frequency range between 3 kilohertz to 1 kilohertz, but in microwave this frequency range between 1 to 300 gigahertz, and in infrared wave this frequency range between 300 gigahertz to 400 terahertz. Okay, that is important. This is important. Radio wave, microwave, and infrared wave. Okay, and radio wave is used in sky propagation. Previously, in sky propagation we use radio wave, and in line of sight propagation we use microwave. Okay, in infrared is used very less, like इन ମାନେ ବହୁତ ପୂର୍ବରୁ କ'ଣ ଥିଲା ନା ମୋବାଇଲରେ ସବୁ ଇନଫ୍ରାରେଡ୍ ୟୁଜ୍ ହେଉଥିଲା और କ୍ୟାମେରାରେ ଆମେ ଇନଫ୍ରାରେଡ୍ ଲାଇଟ୍ ୟୁଜ୍ କରୁଛେ ସେଇ ଯେଉଁ ଫ୍ରିକ୍ୱେନ୍ସିକୁ ଆମେ ୟୁଜ୍ ବହୁତ କମ୍ ୟୁଜ୍ କରୁଛେ ମେନଲି ଆମେ ରେଡ଼ିଓ ୱେଭ୍ ଆଉ ମାଇକ୍ରୋୱେଭ୍କୁ ୟୁଜ୍ କରୁଛେ କମ୍ୟୁନିକେସନ୍ରେ ହେଲା। ଆଉ ରେଡ଼ିଓ ୱେଭ୍ କ'ଣ ଅମ୍ନି ଡାଇରେକ୍ସନ୍ ମିନ୍ସ ଚାରିଆଡ଼କୁ ଟ୍ରାଭେଲ୍ ହେଇପାରିବ ରେଡ଼ିଓ ୱେଭ୍ ହେଲା। କିନ୍ତୁ ମାଇକ୍ରୋୱେଭ୍ କ'ଣ ୟୁନି ଡାଇରେକ୍ସନ୍ ମାନେ ଗୋଟେ ଡାଇରେକ୍ସନ୍ରେ ଯିବ, ଯଦି ଯିବ ଷ୍ଟ୍ରେଟ୍ରେ ଗୋଟେ ଡାଇରେକ୍ସନ୍ରେ ଯିବ। ଆଉ ଇଏ କ'ଣ ହୁଏ ନା ଆମର ରେଡ଼ିଓ ୱେଭ୍ ୟୁଜ୍ ହୁଏ AM ଆଉ FM ରେଡ଼ିଓ ଟ୍ରାନ୍ସମିସନ୍ରେ ଆଉ ଟିଭି ଟ୍ରାନ୍ସମିସନ୍ରେ। ଯେଉଁ ଦୂରଦର୍ଶନ ଟିଭି ଆସୁଛି ତା ଟ୍ରାନ୍ସମିସନ୍ରେ ରେଡ଼ିଓ ୱେଭ୍ ଆମେ ୟୁଜ୍ କରୁଛେ କିମ୍ବା AM FM ଟ୍ରାନ୍ସମିସନ୍ରେ ରେଡ଼ିଓ ୱେଭ୍ ୟୁଜ୍ କରୁଛେ ହେଲା। ଆଉ ମାଇକ୍ରୋୱେଭ୍ କେଉଁଠି ୟୁଜ୍ ହେଉଛି ୟୁନି ଡାଇରେକ୍ସନାଲ୍ ହେଇଥିବା ଯୋଗୁଁ ସେ କ'ଣ ହୁଏ ସେଲୁଲାର୍ ଫୋନ୍ ଟ୍ରାନ୍ସମିସନ୍ରେ ୟୁଜ୍ ହୁଏ ଆଉ ସାଟେଲାଇଟ୍ ନେଟୱାର୍କରେ ୟୁଜ୍ ହୁଏ। ସାଟେଲାଇଟ୍ ଟ୍ରାନ୍ସମିସନ୍ ଆଉ ସେଲୁଲାର୍ ଫୋନ୍ ଟ୍ରାନ୍ସମିସନ୍ରେ ମାଇକ୍ରୋୱେଭ୍ ୟୁଜ୍ ହୁଏ। ଓକେ ଥ୍ୟାଙ୍କ ୟୁ।